So yesterday we saw how the if condition was working. We know there are three selection statements. One is question mark operator, other one is if, one more thing is a switch condition. It is a switch condition. So like that we had there three different types of conditional statements. One can be question mark, one can be if condition, one more is going to be for us it's a switch case. So if is basically either one way or two way branching, but as far as switch is concerned it can be multi-way branching. In the case of switch we write like this: switch followed by here expression, then here it is we have case, then expression 1 followed by here statement or statements. Like this we put it. Either it can be a statement or statements. Like this we can put at the end of this we need to put break. Similarly, we can do with the case expression too. So case expression 2 we can take, and that also executes statement or statements. In the same way, we can have one more like this case expression 3. Even this also can be executing statement or statements. Suppose when none of them are matching, like this we can be having n case, n expressions. When none of them are matching, it can come to default. In the default, this can be getting executed. So here statement or statements. Default is going to be the last statement in this. When none of the expressions are matching, it can come to default. Okay, so here break is required. Without break, what happens here? It can be falling through next block. Suppose case expression 1 we kept here, statement of statements. After that, if you don't have break, it jumps into expression 2. Okay, it can be jumping into expression 2. So like this, it can be going through the the next block of statements if we don't use break. That's why we need to put the break. It is switch expression, case expression 1, case expression 2, case expression 3. When expression 1 is actually getting executed, whenever it is matching, so what will happen here? The statements which follow the expression 1 will be evaluating. Otherwise, it checks with expression 2. If it is matching, these are going to be getting executed. When expression 3 is getting matched, this will get executed. When none of the expressions are matching, so in such cases, it comes to default, it can execute. Default is not mandatory, it's optional. If you want to put, you can put, otherwise you can leave as it is. Okay, now here what we do, we write a switch case. So in this we try to enter a number. There are three possibilities. Okay, so 1 minute. It's not number actually. We are going to use the switch case for the same character. We try to check for we enter a character, whether it's vowel or not we find out. Similarly, whether it's digit or not we found, otherwise it is like consonant or not we find out, otherwise it can be printing as some other symbol. So with the help of the switch case, whatever character is entered, whether first of all there is a vowel or not we find out. Okay, if it's not vowel, whether there is a consonant or not we try to find out. So if it is a consonant, if it's a consonant, we print it as consonant. Otherwise, whether there is a digit or not, we try to find out. When it is neither a vowel, nor consonant, nor digit, it means it is some other symbol. with the help of the switch case, try to do it. We input a character, so whatever character we input, we try to find out in that way. We try to find out in that way. So let us do here with that. And whenever you take switch, it can be working with the boolean values, it can be working with the characters, it can be working with the integers. It can evaluate integers, it can evaluate boolean value, it can be evaluating the characters. So the three things can be evaluated with the help of the switch. Character, integral values, and other thing is here what? Boolean value. These three can be evaluated with the switch case. So let us try to write a new project for that. This is switch case evaluation. Finish. And in this is a switch case. Put it as switch case, we make it. This contains main method, try to then make it this way. But this time we do not pick actually, we don't enter anything from keyboard. Using random class, we try to generate a number. Here write it, import java.util.star. Util.star we take. So with the help of this, we try to create here a random number. Random R&D char we put like this. R&D, it is char is equal to new random. This can give us a random character. This can give us a random character here. So write char ch equal to, put it as char, then here R&D char dot next int followed by here we specify up to 255. Some value up to 255 we can be picking in such cases. We can get up to 255. 0 to 255, it has to pick some value. So first we created a random object, then followed by we are picking here char ch equal to char of R&D char dot next int 256. So here we try to check like this. Right here switch followed by ch. Inside this we can write now the required code. First of all, we look for the vowels. Right here case. Okay, here case actually we put it either okay, switch this is, try to evaluate like this, character dot to upper. If it's character, it can convert, otherwise it can't convert there. Like this, let us try to put. Case it is A. Similarly, then we write here case E. Then write here case I. Then case we put here O. Then write case U. This way you can set it. When it is AEIOU, in such cases, you need to print it as a vowel. These are the 5 vowels we have, I think. A, I, O, U. Then print here system dot out dot println. Here CH is a vowel. Put like this. We can be using, we can write this way. System dot out dot println CH is a vowel. Then similarly, we can put here case. Here we can write 0. Then this is case 1. Then this is here case 2. Then write case 3. Then write this case 4. Write similarly case 5, case 6, or it is case 7, case 8 also we take in this, case 9 we take. Then this is called as here, we should put a break here, otherwise there is a problem with that, we need to put break here. So when case 0 or 1 or 2 or 3, 4, 5, 6, 7, 8, 9, in either of them, it is going to be definitely digit. So write here system dot out dot println. We can write this way, system dot out dot println. It is here CH is a digit. CH is a digit, like this we can print this way. We can put the break here in this. We can put break like this here. Then after this we can go to default. When it is neither a vowel nor a digit, that means what, it is going to be a consonant, or it can be, other thing is what, some other symbols. So put here default. In the default I can use now if condition. I can use here if condition. With the help of that I can find out this one here. So put an if condition, or we can use here nested switch. One switch can be in the other switch. You can use here one switch in the other switch here. So here what I do, boolean right here is alpha equal to, I can put like this, question mark operator I can use here. This is ch character dot is alphabetic. We can take this is alphabetic followed by ch. I put like this ch. So in such cases I put question mark, then write this as here true, otherwise it is false. Like this I can assign here in this. The value I am going to assign in this manner. It can be either a true value or it can be a false value. I assign this way here. So if it is alphabetic, then I can assign in this way. Now here one more switch condition I can use. Switch this is alpha. Inside this now I can put this way. Okay. Spelling is wrong. ALPHA we need to put. Okay, with booleans we can't do. With characters only we can do it. Fine. So Therefore, what we do in this, we can put like this here. This can be taken as, we use this as int. I can put here something like 1 or it can be 0. Use here 0. Then in this, I can set it. Case, this one is here 1. Then print it system dot out dot println. This is exactly what it is here. CH is a consonant. We print like this is a consonant. Like this we print it. Then this is what here, break. Then similarly case 0 we put here, followed by in this, put here system dot out dot println. Write it, ch is some other character. Like this we are going to print it. So this way we are trying to find out whether it is a vowel or not. If it's not vowel, then it is a digit or not. If it's not digit, not vowel, in such cases it checks for the, say, whether it is a consonant or whether it is some other symbol. It can find out for us like this. Let us try to execute this. What we get here, see. Seven is a digit, it's printing for us. So it's picking 7 there. 7 is a digit, it's printing for us. Same manner we try with something else. It says I is a consonant, it says. It is in fact some French character is coming here taking as consonant. E is a consonant, it says like this. Q is a consonant, it says like this. Then some other character, question mark we are getting, it says some other character. Same way, E is a consonant, it's saying this is symbol somewhere in the, Latin they use, I think that. Here some other character, it's printing for us. M is a consonant, it says. Similarly, V is a consonant, it says. We are not getting vowel. It's not picking up. Question mark has come here. So, T is a consonant, it says. This is what some other character it's printing for us. Hash some other character printing for us. So 6 is a digit, it's printing like this. Some other character, space, that is. Space you are getting here, some other character. So we are not getting actually in this the required alphabet. It is saying consonant like this. Either it is taking extended character sets or digits and vowels, but other symbols, it's not picking actually the vowel in this. Either consonants or digits or some other characters, it's printing for us, but we are not getting in this any vowel in this. We are not getting vowel, but vowel also sometimes it can be coming up for us. Vowel also is possible sometimes. C is consonant, it says. N is consonant, it says, because there are more. Since there are more, actually possibilities more with those things. X is a consonant, M is a consonant, it says. C is a consonant like this, it says here. E is a consonant only, it says. U is a vowel, this time we got. U is a vowel. So it's checking with all the things. When it is A, E, I, O, U, or when it is 0 to 9, or if it is, say, some other character, it is going to be giving us exactly. Now instead of checking random number, we can retrieve our own value also in this. So don't initialize this here. Without initializing, using a try block, let us try to read here. Try like this here. Within this, we can read our own character.
Sridhar garu, hello.
Yes, please.
Akkada, you are declaring variable ch, right?
Yes.
What is that dot next in 255?
Dot to uppercase, this one? Next int, okay. Next int
Yeah.
is generating actually next integer. I mean some number it's retrieving between 0 to 255. It can pick any
Why is that
value between 0 to 255. So with this, I am picking a number because some ASCII character I can get out of it. 0
Yes,
to 255 that I am converting into character. I am assigning to CH here. So automatically I want to generate the characters. That's why I am picking it. Instead of I enter from the keyboard. So it is
no.
here
Is
for
there any specific?
random class, random RNDCHR, new random, a random object we created. Using this next int, I am picking the integer, random integer. I am going to pick from the random number generator. So random class is basically meant for generating random numbers. Random RNDCHR equal to new random. It is only reference variable which I created. Now using here next int, I can be picking the random number. Some random number I can be picking from with the this R&D char object. So I specify 255. From 0 to 255, it can pick a number for us. It can pick any number. Because for ASCII values, what is the range? 0 to 255. So I can pick a value from 0 to 255. Therefore, it's picking some number. With that, it's printing actually different things. Like vowel, sometimes consonant, sometimes digit, sometimes other symbol showing. So this is what randomly coming. To check it correctly, we need to manually input. For that purpose now, here I am trying to make some manual input. So put here semicolon slash like this. Then here try to do with the CH. Okay. Now here I enter from the keyboard CH and this is here catch exception EX. Because this part is going to be catching exception because we have to read it. So for reading data, ch equal to here write system.out.println, enter any ASCII character. You can enter some ASCII character. Write here ch equal to, here ch equal to, try to write this way. So it is char followed by, this is system dot in dot read. We can read here some character from the keyboard. We read a character from the keyboard with the help of system dot in dot read. Okay, let us initialize something like here A, try to put here. Trying to put A there. Then after that, this can be even, it's converting into uppercase here, no problem. Now I can input some character. Which one that is? Yes, this is typecasting.
The integers you are converting into
Whatever you enter from keyboard,
okay.
like number, this I am forcefully converting into character. It's nothing but forceful conversion, typecast it is. It's
Okay.
also called as coercion. It can be called as even coercion. So here, whatever number is typed, I can put into char here. Into character, I can be converting this. Because this is numeric format. And one more thing, Java is what? It is a case sensitive language, and other thing is, it is actually very strictly typed language. It does not accept integer data into character. So with the help of typecasting, I can convert the integer into here a character. Java character is what? 2 bytes. It can accept values from 0 to 65,535. But there is a possibility of losing data here. If you take integer, if you enter very big number, because up to 4 billion, 147 million, 384,000, followed by some XXX numbers are there. So you cannot, when you input a big number, it can't be casted to CH. So in such cases, you may lose data. Truncation can occur. But as far as ASCII characters are concerned, this can work fine. What we do here, we are reading data from keyboard, system.in.read. So with this, whatever you type are going to be in the range from 0 to 255. When you read from keyboard, you cannot enter such big characters. You can enter only 0 to 255 because alphabets, sometimes punctuation symbols, then followed by digits. These only you can enter because you are reading from the keyboard. So whatever are available keyboard keys, you can enter. So therefore, there is no problem of truncating any data here. We read from the keyboard, the data whatever we read, now we are evaluating here. Whether that is, we convert it to uppercase, whether we try to evaluate. Whether it is AEIOU anywhere, if it is not AEIO, is it actually 0 to 9? Or is it next thing what it is? Inside one switch, we are keeping another switch. This is called as putting one switch within the another switch. So with the switch here, you have two evaluations again. So one is what? Here default int is alpha equal to character dot is alphabet ch 1 comma 1 colon 0. If it's alphabet, we put here 1, otherwise we put 0. Now based on the switch here, when it is 1, we print it as consonant, otherwise we print it as some other character. So this time we can enter our own character, with that we can test it. Instead of picking random number. Enter any ASCII character, I enter F. It says F is a consonant. Similarly, enter here something like I. It says I is a vowel. It can print like that. Enter some digit here. Digit is something like 7. 7 is a digit. It's printing like this. In the same manner, try to run here. Say something like some punctuation symbol. Question mark I put here. So it says some other character. With the help of switch case, therefore, we are finding out whatever character we entered here. What character exactly, this type of character is what we got here. First thing, whether there is a vowel or not. Second thing is whether there is a digit or not. Then other one, is a consonant or not. When it is neither a digit, nor a consonant, nor a vowel, it prints there, it has a some other type of character. Printing something like other type of character. So like this, it's getting evaluated. So using switch case, we are doing it. In one switch case, we have here other switch case. We have here switch case like this. First of all, cases AEIOU. When it is A, automatically it comes into E. If it's E, it comes into I. If it's I, it comes into O. It comes into U like this. So it's falling through the code. Because all these are vowels. Therefore, even when you enter A, it travels through U. In the U, it's going to be printing for us. When it is O, it starts here and it travels through OU, it prints here. When you enter U straight away, it can be coming to U. Since all of them are actually vowels, you can do like this. In the case of 0 to 9, if you enter 0, it starts from 0, goes through the 9 here. But suppose you enter 8, it's going to take 8 and 9 into consideration. With that, it can be performing it. So like this, they are falling through. But once here after U, you kept a break, then it will not go into 0 and 1. Straight away, it comes out from the switch construction. From switch construct, we come out with a break here. So 2 times, 3 times we used a break. One in the case of vowels, other one in the case of the digits. When neither is a digit nor a vowel, we try to check like this. We go with the default. In the default, we try to find out int is alpha equal to character dot is alphabetic ch 1 colon 0. If it is alphabetic character, it returns 1. Otherwise, it returns 0. So then, with the help of switch case, another switch case we are using inside this default. It's called as nested switch case. So here we write switch is alpha. We write switch is alpha. If it's case 1, we print it system.out.println ch plus is a consonant. It's going to print it as a consonant. Now, when it is not 1, that means what? It's actually other character. Therefore, it comes to this prints here system.out.println ch some other character. So like this, we are using the switch case for multi-way branching. This is called as multi-way branching. With if condition, normally you can do only two-way branching. But as far as switch is concerned, it's endless. You can go with multi-way branching. So this is the advantage of the switch case. So using switch case, we can be doing here multi-way branching operations. Any questions on this? Yes, this is typecasting only. We are forcefully converting whatever we read from keyboard into character. Even the previous case also, it was picking random numbers. We are typecasting it. One is typecasting, other one is conversion. So typecasting is normally called as narrowing conversion. We call it as narrowing conversion. Whereas, widening conversion, automatically it can be getting assigned with the compatible types. So here,
Hello?
yes please.
You only wrote like 9 digits, right? 0 to 9.
Yes.
So I think it's foolish to ask this. Like, but what about double digits or triple digits? It may pick up any number of digits, right?
But see,
10 or 11.
I'm talking only one character. It's not multiple characters. I'm not talking about strings here. I'm talking about only one character.
Okay. Got you.
So in the case of one character, at one time you can enter only one. Either 0 you can enter, or 1 you can enter, or 2 you can enter. It's not actually multiple things. As you said, if it's a
And
number, 100 is containing 3 digits, 100 is a number, but this is what individual digit. So
okay.
here they can be characters from say 0 to 255. Of the 0 to 255, I can input only from 32 onwards. Space to 255 I can input. On the keyboard again, if you take the extended characters, it is not available. From 128 to 255 they are not available here. You have only few symbols available on the keyboard. A space is available. Similarly, alphabets are available, digits are available. Here what I do, I enter only one character. I enter just one character. So what is the character I am checking? I am not checking for the strings in this. See, in the case of strings,
what about
ask is correct, but this is not exactly string. It's only one character at a time I enter.
Okay. And how are you differentiating can you just come down, scroll down a little bit? How are you differentiating consonant and some other character? Where is the logic over there?
See here, int is alpha equal to character dot is alphabetic ch. Okay. So initially what is happening? I enter some character. If it's a vowel, straight away it is actually catching here only. If it's a vowel, here it performs, then you come out from the total switch case. When it is not vowel, therefore definitely it comes to this point here. If entered thing is not a digit, it comes into default part. In the default part, I keep like this: int is alpha equal to character dot is alphabetic ch. Whether the character entered is alphabet or not, we are going to check. Here we are going to check. So if it is alphabetic character, it is assigning a 1 value. Otherwise, it's assigning 0 value here.
Okay.
So if again I am coming into another switch case here. Switch is alpha. If case 1, see, if it is vowel already, that could have been handled on the top itself. Correct? So since it's not a vowel, it is traveling to this part. So when it's coming to this part, if it's alphabet, what it means exactly? It's nothing but consonant only. So that's the way.
Yes.
Switch is alpha. In case 1, system.out.println ch is a consonant, it's printing here. If it's vowel here only, it could have been handled. Correct? It's A, E, I, O, U. This could have been handled here itself. So it could have printed here itself. It's a vowel. Then probably the code might have been broken there and should come out from the switch case. Since it's not catching here, the possibility is what? Either they may be digits or they may be some other symbols or consonants. So by assuming like that, we come into default here. So in this what I have written, int is alpha equal to character dot is alphabetic ch. Whether entered character is alphabet or not, I am finding out. When it's alphabet, it can be both a vowel or consonant. But we gave a provision on the top itself to catch alphabets. If it's not alphabet, for vowel. So if it's not a vowel, therefore it's going to be consonant only. Like that we come to this. So here int is alpha equal to character dot is alphabetic ch 1:0. So 1 meaning is here what? It's a consonant. If it is not consonant, then other symbol that is. So I am using another switch case here. Then I am resolving here. So case 1, system.out.println is a consonant. So if it is not 1, it is going to be 0. In such cases, it's printing as some other character. So like this, we can be using here. Instead of using switch case, we can use if condition also. With if also, we can be doing it. With if also, you can do it. But since we are doing with the switch, I have nested one more switch case within this. Under default, I kept here one more switch. This is called as a nested switch cases. One switch case in the other switch case we are putting. This can be called as here a nested switch case. Like nested if conditions, we can have nested switches also. So, but switch itself writing is boring. Nesting it can become quite boring actually. Normally, switch case also people don't use much. If conditions are quite sufficient for us. With if itself, we can manage. If is going to be more comfortable when compared with a switch. So this is all legacy in fact. Switch is legacy. We have been using it since the C language. So same thing is carried forward to this Java, C#, then JavaScript, then similarly with the PHP, Ruby on Rails, Ruby language, and all these they are using the switch case. It is made for actually multi-way branching, but seldom you find their usage. Regularly you may not be using it very much. Seldom, occasionally sometimes you may use it. Under certain circumstances you can be using. Otherwise, if condition is quite sufficient for us to meet number of conditions. And if he is going to be, you feel if he is going to be more friendly when compared to the switch case. So therefore, here switch you can use for multi-way branching. One switch condition also you can nest in the another switch condition. So here required thing is default. Default is basically when none of the cases are matching, it comes to default. So default is the last block of code in the switch which will be getting executed. So whenever some condition is met here, some case is returning true value, then after that, to come out from the particular code block, we have to use break. If you don't use break, what happens? It follows through, it goes into this one also. Here I don't put any break, what happens in this? It prints both, is a vowel and a digit. I enter here some vowel, it prints both the things. I enter A here, it says A is a vowel, A is a digit. Reason we are not breaking here. Since it is not broken, it's falling through 0, 1, 2, 3, it's printing even like digit. See, A can be a digit also. When you take hexadecimal notation, this can be a digit. Like that also it can be third in fact. Like that also it can be third here. So this way it can be here. But when you put break, it cannot be now. It cannot be part of actually say the particular case 0, 1, 2, 3. So here A2 you have taken, then it's checking actually. So whether it is a alphabet or not, whether it is a digit or not, you can find out. So 0, 1, 2, 3, 4, like this we have taken here. It is treated as here vowel. Whenever it is 0 to 9, it comes into this part, it treats it as a digit. Then in the case of default, it is going to be finding out whether there is a consonant or other character. If it is not consonant, it's going to print other character. So like this, we are using here nested switch cases. Nested switch we are going to use in this way. So this is basically a switch construction. With the help of this, you can do multi-way branching. Okay. So next thing is going to be with the arrays. Before arrays, we require actually the loops. In the Java, we have three loops. One is a while loop, then other one is do while, and one more thing is for loop, and the last one is actually for each loop. We have three loops totally. So first of all, let us look into while loop. While loop is basically meant for executing statements repeatedly. As long as specified condition is met, we can repeatedly execute the loop. So that can be basically a while loop. With the help of while loop, we can be repeatedly executing statements. Statements can be executed repeatedly as long as the given condition is true. As long as given condition is true, we can be repeating the loop. So the statements can be repeated. As long as the condition is true there. So that is called as basically looping. Loop is nothing but control goes back to previous statement, it repeats again. That is normally called as a looping mechanism. You come back to previous code, you execute it. This is in fact called as a backward jump. We are jumping backwards in the code, we are executing, again jumping backward, we are executing, again we can jump backward like that. As long as condition is getting satisfied, we can go back. For that purpose, other languages they support a keyword called as goto statement. With the help of goto statement, control can be sent back to the given label, you can execute. But in Java, it's not supported. Goto statement is not allowed in the Java language. It does not allow goto statement. But other languages they support very much. C language supports, C++ supports, C# supports goto statement. But when you look at Java, it does not support goto statement. So goto statement is actually a little bit confusing statement. When you have multiple goto statements, you can't understand easily code. That can be causing a lot of nuisance. So for simplicity purpose, wantedly they remove the goto statement. But sometimes goto also can be useful. But with the existing constructs, you can make things working in the Java. Rare, seldom such feature may be needed. But in general, in normal day-to-day operations, without using goto statement, we can do. So using structured loops, we can perform the required thing. They give actually readability, and code also can be organized in a better fashion with the help of the standard constructs like while loop, do while loop, and for loop. So a while loop normally works like this. We have here while statement followed by here expression. This expression is going to be evaluating to true. When this is evaluating to true, the statements can be getting repeatedly executed. You can put it as statement or statements. It can be one statement or it can be more than one statement. As long as the expression is evaluating to true, the statements can be getting executed. So that is with the while loop. So with while loop, what happens? You specify an expression. As long as that is evaluating to true, statements get executed. But whenever this this becomes false, statements actually stop getting executed. So while loop is going to be working like this. And inside this while loop, we can use the break statement. At the same time, we can use here continue statement also. We can use both continue as well as break statement. With help of break, we can forcefully come out from the program, and with help of continue, suppose we have statements like this. Inside this we may have more than one statement. So I specify like this: statement 1, then statement 2, like this I have here. Then followed by here, I put certain condition. If this is condition, I put here break. Similarly, another if condition I have here. If condition, I may write here something like continue. I can write continue. Then followed by here, another statements are there. Statement 4. Similarly, statement 5, like this, they can be available. So what happens? Statement 1 is getting executed, statement 2 is getting executed. Certain condition when it is met, you can totally come out from the loop. You can come out totally from the loop. This is called as actually premature end of the loop. Loop can be exited. You are going to exit from the loop when the condition is met here. That means loop is not coming into maturity here. So without evaluating all the expressions, what happens? You are coming out from that. This is called as here forcefully coming out from the loop. This can be called as even forward jump. We are jumping forward. So once you make a forward jump, you cannot come back. So therefore, this is closing the loop. Abruptly in this, inadvertently, the loop is getting closed here. Okay, with the help of the break. With the help of if condition here, continue, what happens? On certain condition, you can go to the beginning of loop. So in such cases, statement 4, statement 5 are ignored. Okay, without executing statement 4, here, without executing statement 4 and statement 5, what happens? Again it goes to beginning, it starts from the statement 1 again. So on certain condition, you can break the loop and you can skip rest of the statements in the given loop. Again you can go to the beginning. So like this we can be using break as well as continue keywords. So using break and continue keywords with those statements, what you can do? Either you can come out from the loop or you can ignore rest of the statements in the loop, then you can again go to the beginning of the loop. So like this we can be using continue and break depending on the requirement there. I'll show those examples, but let us first try to do here with the while loop. So in the while loop, using a while loop, whether the given number is a prime number or not, I find out here. I may enter a number I enter, whether the entered number is a prime number or not, I can find out with the help of the while loop. Okay, here write program Java project. It is for prime numbers. I take this as prime numbers, then finish. Now in this, go with new class. Class name is here prime, and this contains here main method. So inside this, we need to input a number. So for that purpose, we require definitely IO dot star we put, then try to read here. Input stream reader ISR, this is new input stream reader. Followed by this is system.in we put. Okay, this one is a input stream reader we make. Then after that, buffer reader also try to make. We are equal to, this is here, new buffer reader. This is here ISR. Like this, we create a buffer reader. After that, we need to read data from the keyboard for it. Here put try block. Then catch also try to put exception EX. Then this way we make it. So declare here number int num, then int put fact. One more thing is here, boolean is prime equal to, it is, put it as true here. We assign this as true. We are going to assign this as true here, then followed by, we try to here read a number. We read a number now from keyboard, write system dot out dot println, and we need to start reading a number from the 2. We need to start dividing a number from 2, fact equal to 2 we have taken. Println, then here enter any number. Enter any number. We enter a number from the keyboard here. Come to the try block. In the try block, now what I do, I read here num equal to integer dot parseInt. I use here parseInt mechanism. With this, I can be reading data. What is that exactly? This is going to be br dot read line. We use here read line, with that we can read it. Num equal to integer dot parseInt br dot read line. We read into that. Then we try with the for loop, while loop. With that we try to find out. Here put while, write like this, fact is less than or equal to, less than, in fact we can take, less than, it should be, say, num by 2. As long as it is less than num by 2, here we do this way. Here we write, if condition, we use num %2, num %fact it is, num %fact equal to 0. Here we write is prime equal to, what we do, false, we write here, then immediately we break from the loop. Okay, we are going to break from the loop, then here you put this as fact plus plus. Fact plus plus we put, then after the while loop we try to print it. Here write system dot out dot println. Here the number, it is exactly what num, put here is prime is, we can put this one, then followed by take the is prime. So we are going to print in this way. We are printing this way. With the help of this, we can find out whether the given number is a prime number or not. So prime numbers are those numbers, like when we look into this, 2 is a prime, 3 is a prime, 5 is a prime, 7 is a prime, 11 is a prime, then 13 is a prime, 17 is a prime. So these numbers, they don't have any other factors except the 1 and the number itself. In the case of 2, 2 multiplied with 1 only 2, 3 multiplied with 1 is 3, 5 multiplied with 1 is 5, 7 multiplied with 1 is 7, 11 multiplied with 1 is 11. Like this you have. You don't have any other factors. When you take 9, 9 can be multiplied with 3. 3 3s are nothing but 9. In the case of 15, 3 multiplied with 5 is 15. So therefore, 15 is not a prime number, 9 is not a prime number, 21 is not a prime number. So except 2, all other prime numbers are odd numbers. Just 2 is the only even prime we have. So except 2, all other prime numbers, all other prime numbers are odd numbers only. Okay. So when you have number like 7, 11, 13, they don't have any other factors apart from 1 and the number. So in such cases, they can be called as prime numbers. So using this code, now what we do, we may enter a number, then we start dividing that number with 2 till half of that number. Okay. In that process, if the number is divisible by any factor, that means what? Exactly divisible, that means the remainder is 0. In such cases, what does it mean? It's not a prime number because it is having factor other than the number and the 1. So therefore, it is not a prime number. Therefore, immediately when you find such factor, you come out from the loop with the help of the break there. So using break, immediately we can be coming out. Here what we have written, if num percent fact equal to 0, that means if factor is capable of dividing the given number, exactly, that means what? It's having a factor. So when you find a factor like that, what we write is prime equal to false, then immediately we break. So with the breaking, where we come to this point and it prints here, the number num is prime is false, it prints. But here, sometimes you enter number like 17. In such cases, it is going to try with 2 to 8 there. 2 to 8 it tries here. So from 2 to 8 it tries to print it. Never you get actually any remainder like 0. Therefore, the is prime can never become false. Therefore, by default it's going to be prime only. Like that it prints prime. Let us try to execute this here. Enter a number like 11, I enter. It says the number 11 is prime is true. It prints like this. In the same way, try to print here some other number. I enter 15 here. What it says, the number 15 is prime is false. It's not a prime number. It's false like this. It's printing. Similarly, enter something like 47. In the case of 47, what happens? See, the number 47 is prime is true like this. It says. Try to enter here number 1, but it says the number 1 is prime is true. This is wrong in fact. One cannot be called as prime. So therefore, it should not be printed like this. This is a small bug we have in this application. This is called as bug in fact. Compilation is successful, everything is working properly. It does not mean that the code is bug free. This is bug. Like this, bugs can be coming up because this is logical error. So the logical error we need to correct in such cases. One is not logically prime number. When we print it as prime number, that is going to be wrong in fact. Therefore, we need to print here. We need to print it as actually it is a prime number or not. So you can check with this. You can take here if fact equal to 2. If fact equal to 2. In such cases, you cannot take fact equals also 2. Sometimes it can be breaking totally. So instead of that, if num equal to 1, you can put like this, num equal to 1. In such cases, we can print it. If num equal to 1, then print here system dot out dot println. It is neither a prime nor a composite number. Like this it can be printed. And one more thing, whatever number we enter, we need to convert into say a absolute number. For that purpose, we put here math.abs we can use. We can take absolute value. With that what happens, negative numbers when somebody is entering, that also can be here converted to absolute there. So like this we convert into absolute value there. Here num equal to math.abs integer.parseInt br.readline. So like this we try to convert the given number into absolute value. Now with this you can get actually the correct thing. Else we put here, try to now print in this. I enter a 1. So when I enter 1, it says it's neither a prime nor a composite number. But when I enter some other number like 25, it says the number 25 is prime is false. It's not a prime number, it's giving us false like this. So with the help of this code using while loop, we can be finding out whether the given number is a prime number or not. Any questions on this, please? Uday, any questions, please? So the code also we should write in the simplified fashion. So with that, readability factors improves actually. They may have to think more and more, but code if you write in few lines, definitely what happens? Readability factor is going to be improving in this. Now we got very good readability. Very simply, it can be understood without much difficulty. So if you write too many statements, again, that can be leading to confusion. So more better also you can write code. So try to make it more and more concise, more and more better. I have written like this here. I have taken a while loop. With the help of while loop here, fact is what initially 2 to half of that number I try to check this. So with every iteration, what is happening here? The fact is getting incremented. As long as fact is less than or equal to num by 2, the loop repeats here. But whenever the fact becomes equal to num by 2, we come out from that particular thing. So for this, we can take some notepad. In the notepad, what is happening, you can compare. So take notepad. In the notepad, we can be comparing this. We entered here number equal to initially, number equal to I entered 11. Okay, fact equal to how much it is for us, it is going to be 2. Then is prime equal to what it is, this equal to true again here. Now the loop is setting like this. Loop condition is what here? Here write iteration 1. In the iteration 1, what are the values? Here fact equal to 2. Then here num by 2 is how much here? 11 by 2 equal to, it is 5 always. 11 by 2 is going to be 5 for us. So in the iteration 1, what happens? It is coming into here if num percent fact equal to. So here take the 11%, 2 can give you here exactly 1. It's giving 1 for us. So when 11% 2 equal to 1, what will happen? It will not come inside this. It will not come here, because when it's 0, you can come inside this. Is prime equal to, we can set it as false. We can set is prime equal to false, then it can be broken from there. That means you come out from the loop. But what is happening in this? It's the condition is not met, fact plus plus. So with that, where we come to again beginning of loop here. So what happens? Next iteration, that is iteration 2, that is. We have here iteration 2. In the iteration 2, fact value is how much for us? Fact equal to 3, this is now. And here 5 only, 11 by 2, 11 by 3, 11 by 2 only, that is 11 by 2 equal to, again here also it is 5. Next, what we are checking here, 11% 3 we check. 11% 3 equal to 2 we get. Therefore, this condition is again not getting satisfied. Therefore, what happens? We don't come inside this fact plus plus only. We are going to have fact plus plus. So with that, fact value, how much it becomes now? It becomes 3 there, 4. Fact becomes 4. When fact is 4 here, iteration 4 it is. Iteration 3. In the iteration 3, now fact is how much? Fact equal to, it is 4. The next thing is here what? Here it is going to be 11 by 2 equal to, again 5 only. When it is 4, what will happen for us? When it is 4, it is going to be, here 11% 4, with that we try. 4 2s are 8, remainder is 3 here. When remainder is 3, this condition is not getting satisfied. Therefore, what will happen here? Fact will be again incremented. Fact value, how much it becomes now with iteration 4. So now fact is becoming how much? It becomes 5. When it is 5, what will happen? The condition will not be getting satisfied there. Condition will not be satisfied. What is the condition we have here? Fact less than num by 2. Num by 2 is how much? 5. But fact is how much here? 5. Since they are not, since they are matching actually, they are fact equal to num by 2. So without executing this, we come out to this part. We come out from this while loop, and here we check. If num equal to 1, it is not 1 exactly. If num is 1, it prints this. Else what happens here? System.out.println, the number num is prime, num is nothing but 11. 11 is prime is here. Prime is prime, what value we kept on the top? We kept true. It is not getting modified here. So therefore, it's going to print it as prime number for us. Like this, it's evaluating and finding out whether the given number is a prime number or not. Suppose you have taken, say something like 25 we have taken. Num equal to 25 we have taken. So in such case, what happens? Fact equal to, this is going to be 2. Like this we have here, and here we have written is prime equal to, we kept it as here true. We assume that entered number is prime. Now iteration 1, we come to this. Iteration 1, in the iteration 1, fact equal to, we get 2. Fact is how much here? 2. Then this is here 11 by how much we take here. So what is the value for the number? Number is going to be here 25. So 25 by 2 is going to be for us how much it is? 12 you have. It's going to be 12. So 2 is less than 12. Therefore, it comes into loop. 2 is less than 2. And here we try to find out. This is exactly 25 divided by 2 is going to be 1. Therefore, it is exactly what? It will not come inside this if condition. It will not come inside this if condition. Without coming into that if condition, it increments. What increments exactly that is? It's going to increment the, here it's going to increment the fact. Fact equal to, now it becomes 3 here. Then after that, we go with the iteration 2. In the iteration 2, here, fact is how much? Fact equal to 3 for us. Then this 25 by 2 is going to be same, 12 only that is. So condition is getting satisfied there. 3 is less than 12. Therefore, we come into this part. So here what happens? 3 is less than 12. We come into this part. Then here we try to check with 25% 3. This equal to how much we get? We are going to get it as 25, 3 8s are 24. Remainder is going to be 1 here. We get this as 1. Then in such case what happens? Again without coming into loop. We don't come inside the loop because this is not met here. Because number is how much? 25. Fact is how much? 3 there. 3, I mean when you divide the 25 with 3, you get remainder as 1 there. So therefore without coming into this, we increment the fact. When fact is getting incremented, how much it becomes now? Fact will become here 4. Fact is going to be becoming 4 here for us. Okay, then condition is what here? 25 by 2 equal to, here also it is 12. Like so you have here. So next step is what? Again it's going to check. Okay, so this is ended. Then we go with the, here nothing we have, sorry. We don't have anything here like this. Now it is iteration 3. In the iteration 3, here fact is going to be 4 for us. We have fact 4, then 25 by 2 is going to be 12 only. Here also no change with that. Here we check for the 25% 4. 4 6 are 24, we get 1 remainder. So here without going into this particular if condition, because the number is 25, the fact is here, how much fact is going to be here? Fact is going to be 4 here. So when you divide the 25 with 4, remainder is 1. This condition is not getting satisfied. Therefore, simply fact gets incremented. Fact becomes now here 5. So in the next iteration, what happens? This iteration 4. In the iteration 4, here we have fact equal to 5. Okay, then here 25 by 2 is how much? Again 12. So 12 is greater than 4. 12 is greater than 4. It's not 4 here. It must be 5 for us. So 5 is less than 12 or 12 is greater than 5, what happens with this? The condition is not, condition is getting satisfied, therefore we remain in the while loop. We are in the while loop, we remain in the while loop. So we come to this point and check here, num percent fact here, num percent fact 25%, 5 equal to, here we get this as 0. This time we get 0. When we get 0, we come inside this. With this what happens? Is prime equal to, what we set, we are going to set it as false. Then after that, we are breaking code. So without caring rest of the code, we come out from this loop, we come to this point here. Here we are going to check immediately. If num equal to 1, num value how much for us? Num is actually here 25. Therefore, it will not execute this one. It comes to else part, then it prints here. System.out.println, the number num. Num is how much? 25. So 25 is prime is, what was the value we had for is prime? We set it to false. So 25 is prime is false. Like this, it's going to be evaluating for us. So this way, this program is working for us. Any questions on this?
No question, sir.
Okay. Yeah. Thank you then. So we'll meet tomorrow.
Okay, Sridhar garu. Bye.